Hello, my name's Mark Saunders, and this is a YouTube video presentation about describing the dispersion used in statistics. And in this presentation, we're going to be looking at the range, the interquartile range, percentiles, and deciles. You can see other YouTube presentations on research methods and methodologies on my YouTube channel, Mark Saunders on Research Methods, and the link for this is on the bottom left-hand side of the slide. In this presentation, we're going to be looking at measures of dispersion including the range, the interquartile range, percentiles and deciles, and we'll also be going to looking at some further reading as well. Measures of dispersion are statistics that provide an impression of how values for a variable are dispersed around the central tendency. That's the middle value or the average, and we use this to look at numerical data. We either use it to state the difference between a variable's values, and here we'd be looking at the complete range of the variable and its values, or alternatively we use it to state the difference within a subgroup or a fraction of a variable's values, and here we might be using the interquartile range, deciles or percentiles. Another way we can describe this is to describe the extent to which data value is different from the mean, and here we would use the standard deviation. However, for this presentation, we're only concerned with the range, the interquartile range, deciles and percentiles. We calculate the range using numerical data, and we use this statistic, the range, to tell us the difference between the highest and the lowest values. This means our statistic includes the extreme values in a distribution. We're going to look at the annual salaries of employees. This is numerical data, and as the type of numerical data, it's ratio data. This means we can say a salary of one employee is twice as much as a salary of another employee, for example. At the moment, our data are not in ranked order. So the first thing we do when we're calculating the range is to rank the data into numerical ascending order. So from the lowest salary of 16,500 to the highest salary of 94,000. The range is the difference between the highest value and the lowest value. So a lowest value of 16,500 and a highest value of 94,000. Our range is therefore 94,000 minus 16,500, which gives a range of salaries of 77,500. We could say in this case it might well be pounds sterling. We have to be aware because this range is affected by extreme values, and as we can see on the data above, all but one salary lie within the range 16,500 to 47,000. Therefore, the very highest salary of £94,000 affects the range statistic considerably. Quartiles divide our distribution into 4 equal parts. To calculate each of the quartiles, we rank our numerical data into ascending order as before. Once we've done that, we calculate first of all our lower quartile. Because we have an odd number of data points, our quartile lies between values, and the lower quartile is halfway between our second and our third data value in this case. So halfway between 18,000 and 21,000. And this is represented by the value 19,500. Quartile 2 is also our median, and with 9 data points, our median actually lands on an actual data point, in this case the 5th data point, and this is halfway through our data and is at the value of 32,000. Quartile 3 is the third data quartile, and this is 3/4 of the way through our data. Because, again, it's an odd number, this lies between actual data points, and in fact it is halfway between data point 7 and data point 8 for this data set. That's halfway between 35,000 and 47,000, with a value of 41,000. We can also, from our quartiles, calculate the interquartile range. To do this, we rank our data into ascending order, and our interquartile range is the difference between our upper quartile and our lower quartile. Our upper quartile, quartile 3, has a value of 41,000. Our lower quartile, quartile 1, has a value of 19,500. Our interquartile range is therefore the difference between these two values, which is 21,500. But we need to be aware this only represents the middle 50% of all our data values. Our median and our upper and lower quartile represent specific values of percentiles. Once again, once we've ranked our data into ascending orders, we can look at this more carefully. The median, which is the quartile 2, is the 50th percentile, representing halfway through our dataset, in other words, 32,000. The lower quartile, Q1, is in fact the 26th percentile, being a quarter of the way through our dataset, in this case 19,500. Quartile 3, the upper quartile, is in fact the 75th percentile, being 3/4 or 75% of the way through our dataset, with a value of 41,000. Let's now take a closer look at percentiles, first of all, and later deciles, using our same dataset of 9 salaries, which have been ranked into ascending order. And remember, of course, we have numerical data. If we look at this ranked data, the first salary, in this case, represents the 10th percentile, or 1/10 of the way through our dataset. And the middle one, or the median salary at 32,000, is halfway through our dataset, so this is the 50th percentile. The top one, the 94,000, is 90% of the way through our dataset, and this represents the 90th percentile. We can also look at this in terms of deciles, where the lowest salary, in this case, is a dataset of 9 data values. The lowest salary of 16,500 has a decile of 1, and the highest salary has a decile of 9. So we can see that percentiles divide it into 100 separate parts, and deciles divide our dataset into 10 separate parts. In summary now, let's have a look at quartiles, deciles and percentiles. If we look at the values we have at the moment, our quartiles are shown by the red marks. And we have quartile 1 at the 25th percentile, quartile 2 at the 50th percentile, and quartile 3 at the 75th percentile. Our percentiles now divide our dataset into 100 separate things. And obviously it's very difficult to draw 100 little marks here, so I've only drawn each of the 10 percentiles. So we have 0th percentile at the very bottom and the 100th percentile at the very, very top, and then the rest of our values are split in the dataset into every 10%. We could, with percentiles, of course, we would be splitting it to every 1%. And finally, just for completeness' sake, we can see how deciles fit on this. So we've divided our distribution into 10 separate parts. Let's finish by looking at how we'd report these measures of dispersion if we were writing about them. And using this data set of 9 employees from a small business and their salaries, we would say something like annual salaries in the organisation range from £16,500 to £94,000. The median salary being £32,000. So here we're saying what the lowest salary is and the highest salary and what the midpoint is. We then would say 50% of salaries are between 19,500, that's actually our lower quartile, and 41,000, that's our upper quartile, pounds. The interquartile range being £21,500. In terms of further reading, my book with Reeva Berman Brown provides a very, very simple overview of these measures of dispersion, along with the standard deviation as well. Les Oakeshot's book, Essential Quantitative Methods for Business Management and Finance, covers them in Chapter 5. And my textbook with Phil and Adrian, Research Methods for Business Students, looks at these measures of dispersion, along with other measures of dispersion, in Chapter 12. I hope you found this video presentation useful. Please do subscribe to my channel, Mark Saunders on Research Methods, which I'm trying to add to on a regular basis. Thank you.